Today, I want to take you on an incredible journey through one of the most fascinating corners of the universe, the galaxy cluster Able 2744, also known as the Pandora cluster. Imagine a place filled with hundreds of galaxies, each unique and full of mysteries. The diversity in a cluster like Able 2744 is surprising. You will find massive elliptical galaxies that are old and form very few new stars. Then there are the spirals, with their well-defined arms and regions full of star formation. This variety is more than just attractive, it's key to understanding how galaxies evolve. Gravitational interactions between these galaxies can trigger mergers, changing their shapes and futures forever. Located about 3.5 billion light-years away from us, Able 2744 is a cosmic laboratory for studying these dynamic processes. But that's not all that makes the Able 2744 special. This cluster is one of the best examples of a merging cluster. Imagine several smaller clusters colliding, creating a cosmic dance of galaxies. These extreme interactions result in some mind-blowing phenomena, like gravitational lensing. This is where light from even more distant galaxies is bent and magnified, allowing astronomers to peer into galaxies that would otherwise be invisible. Now, let's change the subject for a moment. As we explore the universe, I can't help but mention another incredible phenomenon, this time within our own solar system. At Saturn's North Pole, there is a storm unlike any other, the hexagonal storm. First spotted by the Voyager spacecraft and later studied in detail by the Cassini mission, this storm has an almost perfect hexagonal shape. Each side of this hexagon is about 14,500 kilometers long, and the entire structure is large enough to accommodate 4 Earths side by side. It rotates clockwise, completing a full revolution in about 10 hours and 39 minutes, mirroring the rotation of Saturn. The exact cause of this hexagonal shape is still a mystery, but scientists think it may be related to atmospheric jet streams and rotating fluid dynamics. Unlike storms on Earth, which are driven by surface heat and influenced by terrain, Saturn's hexagonal storm takes place in a dense, gaseous atmosphere without any solid surfaces. This shows how different the climate can be on other planets, highlighting the complex atmospheric dynamics at play. And while we're talking about fascinating celestial bodies, let's not forget Mimas, one of Saturn's moons. Its most striking feature is the enormous crater Herschel. This crater is around 140 kilometers in diameter, almost a third of the moon's total diameter, and approximately 10 kilometers deep. The crater's central peak rises impressively about 6 kilometers above the crater floor. Scientists believe that Herschel crater was formed by a colossal impact from a celestial body, perhaps an asteroid, billions of years ago. The impact was so intense that it almost broke Mimas, but the moon held firm. Studying craters like Herschel helps scientists understand the geological history and dynamics of our solar system. Provides clues about the frequency and magnitude of impact events over time. So, whether it's the rich diversity of galaxies in Able 2744 or the mysterious hexagonal storm on Saturn, the universe never ceases to surprise. Thank you for joining me on this journey through the cosmos. If you enjoyed this content, don't forget to like and subscribe for more stellar explorations. Until next time, keep looking up.